We will end this SEEP session with a few comments on modeling methodology and modeling philosophy. Generally, a geotechnical numerical model needs to be a simplified abstraction of a complex reality. Let me repeat that. It needs to be a simplified abstraction of a complex reality. Our model should not seek to replicate every detail in reality. If you have too many details, it can make it impossible to interpret the results. And good modeling practice dictates that the model must be designed to answer a specific question. And so when you start modeling, it is important to be clear in your thinking as to the question that you seek to answer. Simply saying, I want to analyze this case is not adequate. A clearer picture as to why you are doing the analysis needs to be formulated in your mind before you start doing them. We have 3 recommendations. Start simple, start simple, start simple. This is not meant to be funny because we all are human, and we invariably at the start make our analyses too complex, and I personally fall into that trap myself sometimes, and then it is too complex, I cannot interpret the results, and then I have to take away details until I understand the results, and then once I understand the results I can go back and add the detail if necessary, but all too often at that point it is, once we understand the flow process, we recognize that the details are not necessary and not important to the understanding. As a very, very rough rule from all of our experiences of geotechnical numerical modeling over many, many years, we recommend that you should spend about 20% on the geometry, 40% on material properties, and 40% on boundary conditions. It is a tendency of us as human beings that we always tend to spend our time on the thing we know the most about, and as a result we spend most of our time on the geometry, and we might produce a beautiful cross-section, but if we don't know anything about material properties and boundary conditions, the beautiful geometry and the detailed geometry is of no value. So something to keep in mind when you're modeling: keep the model and the geometry as simple as possible, and then spend all of your time on material properties and boundary conditions, and then later, if you wish, and once you understand the system and the processes, then you can go and make a more detailed geometric cross-section if you need that for presentation purposes or for discussion purposes with other engineers. If you are spending more than about 20% of your time on the geometry is likely too complex. And increased complexity does not necessarily mean more accuracy. And the rule is you should include just enough details to understand the flow mechanism. In our SEEP engineering book in Chapter 2, we talk about modeling guidelines. Once again, on the handout CD, there is a folder called Papers of Interest. There are 2 papers there by Barber and Cron that I would urge you to read. They are on modeling. Is it prediction or process? And the second article is on the same subject. They are relatively short articles, and it would be well worth your while to spend some time reading these short papers to help you in your numerical modeling, and it certainly helps you understand our thought process in the design and use of SEEP and the recommended use of SEEP. In the end, as we explain in these modeling papers, Please remember, if you cannot explain the results, they are likely not correct. This is extremely important. If you cannot provide a logical explanation for the results, then the thinking is that the results may not be correct, in fact. Alternatively, sometimes the results may be correct, but they don't. You need to improve your understanding of the fundamentals. If you cannot interpret the results, then perhaps it is, in some cases, a lack of understanding of some of the fundamentals. And then when you do some more study and you understand the fundamentals, then all of a sudden, yes, it makes perfect sense. And so we need to be able to make a logical explanation of the results. If we can't, then the results may be incorrect, or if the results are correct, then we should be able to make a logical explanation of the results once we have a greater and deeper understanding of some of the fundamentals. Here are some references related to the SEEP-W analysis that we have mentioned at various points throughout the sessions. This brings us to the end of our SEEP-W workshop sessions.